All right, well, my name is Stephanie Schmidt. I'm a graduate student at the University of Illinois. And today I'm going to be presenting about some of my thesis work investigating the effects of water level manipulations on predation risk at marsh bird nests. First, I want to take a moment to kind of familiarize you with marsh birds because they're not a single taxonomic group of birds. Marsh birds are a group of wetland-dependent water birds and include bitterns, herons, rails, and grebes. These birds are often very secretive in nature, and they reside in dense emergent vegetation such as cattail and bulrush, and they're very cryptic in nature and they rarely vocalize. All of this has contributed to these birds being relatively understudied and undersurveyed. Unfortunately, marsh birds are also experiencing widespread population level declines, so there exists a need to identify the sources of these declines and manage for them. One identified source of marsh bird declines is wetland habitat loss and degradation. As you can see from this map of Illinois, Illinois is a pretty heavily disturbed landscape. Around 90% of hydric soils in the state were drained by the 1980s, and the majority of that drainage occurred in the northern two-thirds of the state for agricultural expansion and urbanization. Another identified source of marsh bird declines is predation. Predation accounts for around 80% of reproductive losses in all bird species, so it's important for us to consider here with these vulnerable marsh bird species because reproductive losses can have long-term population level effects. Studies have also suggested that habitat loss, degradation, and fragmentation may be leading to an increase in predation risk for these birds because the breaking up of the habitat is increasing predator access to nests over time. So what it appears to us here is that these habitat level factors may be the root causes of marsh bird declines. Consequently, studies have also suggested that proper management of existing and restored wetland habitat may help to mitigate these losses. And one of the management or restoration techniques that is used is moist soil management. And of course, that's what's used at Emiquon Preserve. Pictured here is a pump that sits in the levee that separates the Illinois River from Emiquon Preserve. And the purpose of this pump is to seasonally and cyclically manipulate water levels at the preserve to manage for diverse wetland habitat. Emiquon uses this pump to manage a very dynamic wetland drawdown approach. And the dynamism behind this approach is that these drawdowns can be minimal, moderate, or intense, and that intensity will change cyclically to manage for a variety of wetland species. As we heard from Doug, in 2020, the preserve implemented what we would categorize as an intense drawdown, and they pulled around 4.5 feet of water off of the preserve. So how these drawdowns work is water is pulled off from the spring through the summer, and mudflat is exposed during that time. That exposed mudflat is beneficial for moist soil plant species such as millet and smartweed, which are able to germinate under these conditions. And these plants will eventually produce energy-rich and carbohydrate-rich seeds that will feed migrating waterfowl in the fall. The drawdowns are also beneficial for shorebirds that are able to forage on this exposed mudflat, and it's beneficial for fur bearers that are typically deterred by deeper water. So when water is pulled off of the landscape, these fur bearers can access the marsh interior and resources that were inaccessible to them before. So we know that these drawdowns are benefiting a variety of wetland species, but we're concerned with how they may be impacting some of these more vulnerable and secretive marsh bird species, especially during their nesting season. So most marsh birds will initiate nesting between April and May, but these drawdowns aren't being initiated until mid-June. By mid-June, our birds have already selected their nest sites for their access to food resources, their limited competition, and their protection from predators, and they've made reproductive investments by laying eggs in their nests at this time. The concern here is that water drawdowns have the ability to change the habitat, and they can change the habitat around a nest enough to be opening up access to the nest for these predators, therefore increasing predation risk at the nest. So our first concern with these water drawdowns lies with vegetation structure. Marsh birds want to nest in sites that offer the greatest concealment, because greater concealment means greater protection from predators. But if these drawdowns have the ability to change vegetation structure, such as height or composition, birds may be nesting in sites that offer less concealment and put them at greater risk of predation. Our next concern lies with water depth. Marsh birds want to nest over water because it provides protection from terrestrial predators like those fur bearers that I had mentioned before that are typically deterred by deeper water, and it provides access to food resources such as fish, aquatic invertebrates, reptiles, or amphibians. But what we're seeing is that as water is being pulled off of the landscape and mudflat is exposed, this water's edge is moving closer to the nest, and the water below the nest may be becoming more shallow, which may be increasing access by these terrestrial predators. So here in isolations initiated after marsh birds are nesting, increasing predation risk and placing these birds in an ecological trap. The first objective of this study was to determine the spatial and temporal variables that are influencing predator access to marsh bird nests when predator identity is ignored. And the second objective of this study was to address the same question when predator identity was acknowledged. So the first step in this study was to define which marsh bird species we're going to focus our study on. And we wanted to focus on some birds that we knew were nesting at Emiquon Preserve from past records and are some of the more vulnerable species in the state. So the first bird that we were interested in is the least bittern. Least bittern is a small cryptic heron species that nests in elevated plate-like nests on vegetation edges and over relatively deep water. And this bird is listed as threatened in Illinois. Our second study species is the American coot. This is a common native diving rail species that lays large clutches of eggs in floating platform nests that are anchored to vegetation edges and over relatively deep water. Our third study species is a common gallinule. This bird is behaviorally and morphologically very similar to the American coot, but it's far less common and it's listed as endangered in Illinois. The common gallinule can also build elevated plate-like nests like the bittern and floating platform nests like the American coot. And our fourth and final study species was the black-crowned night-heron. This bird is a colonial heron species that nests in rookeries, either in trees or in dense cattail vegetation like it did at Emiquon Preserve. The black-crowned night-heron is also listed as endangered in Illinois. Next, we wanted to locate the nests of our species of interest, so we surveyed 81 plots at Emiquon Preserve that were defined as dense emergent vegetation or hemi-marsh conditions from a 2019 vegetation cover map. We also surveyed for incidental nests between these plots in areas that had both optimal vegetation conditions and increased marsh bird activity. And for each nest that we found, we marked the nest and revisited every 1 to 4 days to document fate. And at each nest revisit, we collected a set of spatial and temporal variables, which I will discuss further later. Finally, we set up nest cameras at a subset of our nests to continuously record activity at the nest and document instances of predation. Past studies have found that using marks on eggs or tracks around a nest is relatively unreliable for identifying predators, so this helped us to alleviate some of that uncertainty. We also wanted to make sure that these cameras didn't have any significant effect on nest success, so we concealed the cameras using paint and vegetation and tested their effects with logistic regression. The results of this test suggested that the cameras did not have any significant effect on nest fate, which was great for us moving forward. We were unable to test the effects of the cameras on the American coot, however, because we only had one active coot nest throughout the season. Next, we wanted to address the effects of the habitat manipulations on survival. And our first step was to divide our variables into spatial and temporal models. Our spatial models can be thought of as our habitat variables. And here we looked at water depth, distance from the water's edge, nest height, and average emergent vegetation height. And our temporal models can be thought of as activity around the nest. And here we looked at clutch size, day of year, nest stage, and our competitive spatial models. We had divided it this way with our spatial and temporal plus spatial models because past studies have suggested that activity around a nest may not necessarily increase predation risk on its own, but could increase predation risk when coupled with habitat variables. So what this is saying is that predators need to first have access to a nest before they can then pick up on these activity cues. We then use these spatial and temporal models to address both objective 1 and objective 2 of this study. And first we addressed objective 1. This was where predator identity was ignored. And we found for the common gallinule and the least bittern that water depth was a significant predictor of nest fate. And what we're looking at here is a daily survival rate graph. So on our y-axis is our daily survival rate. And values closer to 1 mean that it's more likely to survive, and closer to 0 means that it's more likely to fail. And on our x-axis is our variable of interest, which here is water depth. So what this graph is showing us is that nests in deeper water were more likely to survive, and nests in more shallow water were more likely to fail. We also found that distance to the water's edge was significant for these two species as well. And what this is showing us here is that nests that were further from the water's edge were more likely to survive, and nests closer to the water's edge were more likely to fail. What this is implying is that these drawdowns may be important for determining survival of nests, but we still want to know what is causing these losses. So our next step is to identify the predators, because that information is more informative for management decisions. It will tell us who is causing these nest losses and who is benefiting from these drawdowns. So that takes us into objective 2, where predator identity was acknowledged. And our first step here was to divide our predation events into separate classes. And the classes that we had chosen were mammal, reptile, and other. In our mammal and reptile classes, we observed raccoons, mink, and fox snake. And these three are common generalist wetland edge predators. And in our other category, the majority of our losses were abandonments. So first, we looked at the direct effects of the water drawdowns and looked at water depth and distance from the water's edge. And we found that both of these variables were significant for mammals. And what this relationship is suggesting is that nests in deeper water and further from the water's edge are more likely to survive, and nests in more shallow water and closer to the water's edge are more likely to be predated by mammals. So in our mammal category, again, we observed raccoons and mink, and they're common generalist wetland edge predators, but their movement is typically limited by deep water. So what we're seeing is that early in the season when water levels were high, our mammal predators are going to be preying on nests that are occupying the same edge habitat that they're using. But later in the season, when water is pulled off of the landscape, that usable edge habitat for our mammal predators is shifting towards the marsh interior and opening up access to these nests that were previously safe from predation. So what we're seeing is that these mammals are shifting towards the interior as well and preying on these nests later on in the season. This is supported by past research, which has found that raccoons will concentrate their activity on habitat edges and selectively hunt in wetlands, and that deep water can act as a barrier to terrestrial predators. Next, we found that day of year was significant for both the reptile and the other category. In the other category, what this relationship is implying is that nests later in the year were more likely to experience a loss than nests earlier in the year. And despite this being statistically significant, the biological significance behind this relationship is relatively unclear right now. If you remember the other category, the majority of our losses were abandonments, and we had some predation events in there as well. It is unclear if these late season losses are a result of the drawdowns opening up access to these nests and allowing predators to find the nests, or if because these drawdowns are creating such poor quality habitat for our birds that they're abandoning it, or if these late season losses are a result of abandonments from a life history trait. Some birds may abandon their nests later in the season if they believe that the eggs that they are sitting on are unlikely to reach independence by the time of migration and are not worth the continued incubation investment. In order for us to determine if this is a life history trait or a result of the drawdowns, we will need to investigate drawdown intensity in this upcoming field season. For the reptile category, this relationship is suggesting that nests earlier in the year were more likely to be predated by nests later in the year, and we do believe that this is related to the drawdowns. So in our reptile category, we observe fox snakes. And fox snakes, again, are common generalist wetland edge predators, but they're also very capable swimmers. However, their movement is typically limited by vegetation structure. They rely on dense vegetation cover to provide protection from their own predators, which are typically aerial predators. So what we're seeing is that early in the season when water levels were high, our fox snakes are going to be preying on nests that are occupying the same vegetated edge habitat that they're using. But later in the season, when water was pulled off of the landscape and this unvegetated mudflat was exposed, this area proved to be much too risky for our fox snakes, and we believe that they were unlikely to move towards the marsh interior despite being physically capable to because of the increased risk, and as a generalist edge predator, they can find alternative food sources. Finally, we found that clutch size was significant for both the mammal and the reptile category. And what these relationships are implying is that nests with larger clutches were more likely to be predated by mammals or reptiles than nests with smaller clutches. And we believe that this comes down to detectability. These larger clutches are going to give off more visual and olfactory cues and therefore be more detectable than smaller clutches. The caveat here, of course, is that these nests need to already exist in habitat that the predators have access to so that they can pick up on these activity cues. So what we can conclude from this study so far is that it appears that water drawdowns are associated with an increase in general nest loss, and this nest loss appears to be fueled primarily by mammalian predation. These water drawdowns are pulling water off from below the land or from below nests, moving the water's edge closer to the nest, which is increasing access to these nests by these terrestrial predators. It also appears to us that larger clutches in nests that are already within predator habitat are more likely to be found and predated, and we believe this is because these larger clutches are more detectable than smaller clutches. In 2021, we plan to continue this study, but we will also be investigating the effects of drawdown intensity, vegetation density, and parental activity on nest success. This spring, we are using mist nets and audio lures to capture migrating least bitterns, and we're going to be attaching radio tags to them. For the birds that continue to stay through the summer and nest, we will track their activity around their nest and see how that may be influencing predation risk for these birds as well. This summer, we are also planning on investigating the effects of post-fledgling survival and habitat use on least bitterns. Most management decisions for birds are informed by adult habitat use or breeding adult habitat use, but studies of birds in various habitats have suggested that the post-fledgling period habitat decisions are different from those in adults. This is also critical for us to understand because the post-fledging period is a period of time when young birds are facing the greatest risk of mortality. So the goal of this study is to determine if the different habitat use is present in least bittern post-fledglings versus their adult counterparts, and if these habitat decisions may be influencing survival of these birds. And the overarching goal, of course, is to better inform management for this threatened Illinois bird. As I wrap up here, I do want to say thank you to everybody who's helped with this project, especially my technicians, Nora Hargett and Cheyenne Stevens, the staff at the Forbes Biological Station, and the Nature Conservancy for allowing us to do our research at Emiquon Preserve. And I also want to say thank you to everybody who has helped with this to help fund this project and open it up to any questions that you may have for me. Thank you.